Hello friends, welcome to another session of C#.NET Programming by Example. This is part 2 of this series. In today's session, we are going to cover keywords, variables, data types and operators. Please subscribe, comment, share, like the videos on this channel. Okay, let us start with today's topics. The topics which we are going to cover today are keywords, variables, data types. Under data types, we will take a look at value types and reference types. And later on, we will look at operators and different types of operators. Okay, let us begin with looking at keywords. Okay, what are keywords? Keywords are those predefined reserved identifiers that have special meaning to the compiler. That means these are the keywords which are already used by the compiler and they cannot be used as identifier in your program unless they include at as a prefix. So that means these keywords are already used in compiler, so we cannot use them as it is, but we can have at prefix. The following list provides the list of keywords Okay, so this is the list of keywords: abstract, as, base, bool, break, byte, case. So these are all the keywords which cannot be used as it is as a name of the variable. Okay, so there is another list here. Only thing to remember here is you cannot use them as name of your variable. Let us take a look at data types now. Data type is a classification that specifies which type of value a variable can hold or store. There are two types of data types. One is value type, the other one is reference type. In value type, variable stores the data, and in reference, the variable stores the reference of the data, which are also called objects. And under value type, assigning one value type variable to another copies the contained value, but in reference type, assigning one reference copies a reference to the object but not the object itself. That means in value type, assigning one value type variable to another just copies the actual data. But in reference type, both the references will be pointing to the same data. Okay, it is also possible to convert the data types from value type to reference and vice versa. So now comes boxing and unboxing. Unboxing, since there are two types, value types and reference types, the data types can be converted from value type to reference type and reference type to value type. Converting value type to a reference type is called boxing, and converting reference type to a value type is called unboxing. In .NET, boxing is implicit and unboxing is explicit. Okay, let us take a look at value types. Value types are broadly classified into structs and enumerations. Under structs, we have numeric type, Boolean, and user-defined structs. And numeric type of value type is again classified into integral type and floating type. Under value type, as we have seen, under structs there is a numeric value type, and under numeric also there are two types of value types, which is integral type and floating type. We'll take a look at what these integral and float type are. These are basic data types which has specific data storage assigned to them. For example, if you take an integer, so to store an integer, the compiler will assign a 32-bit memory. Okay, for S byte, it assigns a 8-bit memory, which is 1 byte, and it holds the values ranging from -128 to 127. So if you're having a byte is also an unsigned 8-bit integer value. So that means it is an unsigned byte, so which stores the range of values starting from 0 to 255. So you can take a look at the other data types and their storage range and the size of the memory which gets allocated as soon as we create a variable of these types. Okay, for a float type, the range is defined here, but for float, double and decimal, it is based on the precision. So float has got 7-digit precision. That means after decimal point, you will get the accuracy till 7 digits. And for double it is 15 to 16 digits, and for decimal it is 28 to 29 digits. Okay, so let us take a look at operators now. In operators we have different types. One is assignment, the other one is arithmetic, relational, logical, unary, ternary, bitwise, and compound assignment operators. Under assignment you have only equals. Under arithmetic you have plus, minus, star, which is multiplication, and slash, which is division, and then modulo operator, which is percentile. Under relational you have double equals, greater than, less than, greater than or equal to, less than or equal to, and not equal to. Under logical you have double and double or. Under unary you have plus plus and minus minus. Under ternary you have a question mark followed by a colon. All these operators we will take a look at in the next chapter when we cover the conditions. Okay, so now let us switch over to Visual Studio and take a look at some of the examples related to the topics which we covered just now. Okay, so let us go to File, New, create a project. I'm going to create a console project, which is console app, and I'm going to set the location. I'm going to call this as part 2, which is .NET part 2, and click on OK to create the project. Okay, by default it has created a main method. Inside this we will take a look at now defining a variable. Okay, so to define an integer variable, I'll type in int I is equal to 10. Here I is a variable of type integer which holds value 10. So every statement, executable statement, should be followed by a semicolon. Okay, I will also define a string. So yes is a variable name of type string. Which holds hello. So f is a variable of type float which holds value 3.2. So this is how you declare and initialize the value. So here all the below variables are declared and initialized simultaneously, but I can also do first a declaration. So this is declaration, and I can initialize the value, or I can assign the value later on. Assign the value a to previously declared variable c. Okay, let us take a look at this integer I is equal to 10. Okay, let us take a look at the example of I is equal to 10, which is declared as int, and let us see how that gets stored in memory. Since we know that integer takes 32-bit, so we have divided that 32-bit into 4 different blocks, which is of each byte. So this is first byte. So this will be second, and this will be third byte, and this will be fourth byte. So now the value of int is, since the value of integer is equal to I is equal to 10, so now this is represented in binary as 1010. 0 is at 2 to the power of 0, and 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So eventually our first byte will look something like this, so which will be divided into so 10 will be represented in this manner, which is, so here we will have 1, so here we will have 0, 1, 0, and all others will be zeros. Okay, so this is only the first byte which we are talking about. Here to here, it is the first byte. Okay, so since this is a small number and the first byte is good enough to store this value, all the other bytes will be zeros. So this is how it internally stores the value of I. Okay, now let us take a look at printing these values. So to print these values, we will put it in console dot write line I, value of I. Instead of that, we will type in CW tab C, then S, F. So first thing is we will compile this project, build, and then build the solution. And then we'll execute the program. So as you can see, it has printed the values. I is equal to 10, and then C is equal to A, S as hello, and then F as 3.2. As we have seen earlier that keywords cannot be used as a identifier. Let us try to use one of them, int as equals to 200. So since as is a keyword, it is giving me some error here. Let us take a look. Invalid expression term as. So if I add a prefix at here, so that will become a variable which I can also print. So at as, again control F5. Okay, so the 200 gets printed here. Okay, so now let us take a look at boxing and unboxing. As we said, boxing is converting value type to a reference type. So here let us say int val is equal to 100. So now if I want to convert this, so this is of type value type. Suppose say I want to convert this from value type to a reference type. I need to have an object variable which is defined as an object var is equal to val. So that means this statement will convert the value type to object type. So the value gets stored into var. Okay, so this is converting a value type to an object type, which is called boxing. Now let us take a look at unboxing, in which we are going to convert let us take a look at unboxing, in which we are going to convert an object type to a value type. So here int unbox I will add var. So here this will convert object type to a value type. So now since I'm getting an error here, let us take a look at cannot. So it says cannot implicitly convert a type object to int. An explicit conversion exists. So that means whenever we do boxing, that means converting a value type to an object type, it is implicit. So that means we don't have to specify explicitly which type of object it is. But whenever we convert from an object type to a variable type, we have explicitly say which type we want to convert that object type to. So in this case, we want to convert that var, which is an object which is currently storing an integer value. To convert that, we have to typecast it to an integer. So this is how we typecast it to an integer. Now, as you can see from this statement, boxing is implicit but unboxing is explicit. So during unboxing, we have to specify which type you want to convert that object type to. Okay, let us print the values after boxing and unboxing. To do that, again console.writeLine. Okay, so let us press Ctrl F5 again to see what value we are going to get. Okay, after it has converted, after boxing, the value is 100, and then after unboxing also, the value is 100. Okay, that is the end of today's session. Please subscribe to this channel, share it, comment, and then like the videos on this channel. Thanks for watching.